Today our lesson is 10.5. It's talking about trigonometry and area. In this lesson, we learn how can we find the areas of regular polygons and triangles using the trigonometry. Let's start now. How can we find in this? Today we will learn how can we find the area of a regular polygon using trigonometry. Let's start now with this problem here. What is the area of a regular nonagon with 10 centimeter sides? So here, as you see, we have a nonagon. Nonagon, that means we have 9 sides. So here we have
Teacher, can you admit Rose?
Yes. One, two, three, four. One, two, three, four, five, six, seven. Let's make it 8. And as an example, this is a shape from 9 sides. Now I want to find its area. Now tell me that also. With 10 centimeter sides, so that the length of each side here is 10 centimeter. Auntie asked me to find the area. I think we solved like it. So here now we have.
Teacher?
Yes.
Teacher, can you let Rose enter?
Monsieur, here name is not appearing to me. So now here the side is 10 centimeter. Here is the center, and I want to find the area. As we know before, that the area of the polygon is half the apothem times the parameter. So what do I need? I need the apothem and I need the parameter. How can we find the parameter?
By using n times
by
s.
adding all the sides or multiplying the length of one side by the number of sides.
Yes, so the parameter here is n times s. How many sides here we have? We have 9 sides.
9.
How many? Sorry. What is the length of each side? It is 10. So the parameter here is 90. So we know the parameter. So now we need the area. The apothem. How can we find the apothem? Let's see. First, from this lesson, as we say, trigonometry and area. So I need one of the trigonometric functions, sine, cosine, or tan. So let's make now a triangle. That's its base. One from the base of the triangle is a side of a nonagon. Then after that, as you see from here, if this is 10, as you say, and there's a line that's perpendicular on the base, we name it with A. So let's focus on this triangle here. Let's take it here. So as we say, we take this triangle that we draw it inside our Pentagon and we solve on it. So now here we say that the area or the length of the base is 10. So half of the base, it will be 5. Why I need half of the base? Because I want, because as you know, the trigonometry is used in right triangle. So I need now to use only right triangle. As an example, I want to use this right triangle. So if I want to use this right triangle, I have it now here. If I have it here, this A, it will be the apothegm, and I need the length of the base. But I know that the length of this triangle, or the base of this triangle is 10. So what is the base, the length of this base will be? It will be 5. Yeah, which is half of 10. Okay, because here, this is the triangle. From this point to this point, it is 10. Half of it is 5. That's why I say 5. Then after that, so this is 5, this is A. For the trigonometric function, I need 2 sides and 1 angle. I have the 2 sides, but where's the angle? I need an angle. To find the angle, as we said, we have this point. Let's find now the angle, or let's find now the central angle. To find the central angle, what will you do? To find the angle.
360 divided by 9.
Thank you. We will divide 360 divided by 9. Why 9? Because the number of sides, he told me that it's a nonagon with 9 sides. Then it will be 40. So the angle in the center here between 2 radius, between 2 radii is 40. So this big one here is 40, as we said here. So half of 40, it will be 20. Now my triangle is ready. I have an angle 20, I have a side 5, and I have a non-apothegm. Now the next step, which function shall I use? Now as
Tangent.
before, yes. Now which function shall I use? The sine or the cosine or the tan?
The tan.
Yes, hello. So the sine here, let's remind you, the sine and cosine and tan. The sine, as we know before, it is an opposite over hypotenuse. The cosine is an adjacent over hypotenuse, and the tan is an opposite over adjacent. This is the sine, cosine, and tan. Now look at here. Here I have, I need A. For this angle, 20. What did you have? You have an opposite side and you have an adjacent. So which from these functions have an opposite and adjacent? The sine or the cosine or the tan?
The tan.
The tan. So I will use the tan now. So tan 20 is an opposite over adjacent. So tan 20 is 0.36 equal. What is the opposite side for the angle 20? It is 5. And what is the adjacent side for 20? It is an apothem 8. Then by cross product 0.36a is equal to 5. Then over or divide by 0.36, divide by 0.36, then let's divide 5 over 0.36. We have, or we found now that the apothem here, by that we find now the apothem is 13.88 centimeter. So by now we find the apothem. Now let's go back here. Let's go back now to the question. In this question, I need the area. And as I told you, the area of a polygon is half AB. So now let's go back to find the area of the shape. As we said from here, the area is half AP, and we found that the perimeter is 90, and we found that the apothem, that's what's written here, 13.88, that we solved using the trigonometric times half, we can get the area of the polygon. So 45 divided by the answer. So the area, it will be approximately 625 centimeter squared.
I think we did this, right?
Yeah. He just in this today I will repeat all that I said in the previous lesson, but here we will focus only how can we find the area of a polygon using trigonometric function. Tomorrow we will talk about a triangle. Okay. Now, let's solve this gutted here. In this question here, what is the area of a regular pentagon with 4-inch side? We will do the same steps. Here now, we have a pentagon. So, we have 5 sides. Then The side here is 4. So I need now to find the area. The area of the pentagon is half the apothegm times the perimeter. I need to find the perimeter and the apothegm. The perimeter is NS. How many sides for the pentagon? They are 5. So we have to multiply 5 times. What is the length of each side?
4.
4. So the perimeter here is 20 inch. So this is for the perimeter. I found it. The second step, I need to find the apothegm. How can we find the apothegm? Where's the apothegm first? The apothegm here, this is the center of the shape, and here will be the apothegm. So to find the apothegm, I will draw a right triangle, as I told you. And in this right triangle can help me to find the apothegm, because here is the apothegm A, and since the base is 4, and since this apothegm is bisecting the base, so the base of the right triangle will be 2 here and 2 here. So now for this triangle here, let's use it now. We will have an apothegm, we will have 2, and we will have, this one, 90. And now, as I told you, if you want now to find the apothegm, the only thing that helped me or the 2 things in right triangle that helped me to find any unknown element in it, Pythagorean or the trigonometric function. Both of the Pythagorean and the trigonometric function work only in right triangle. So every time if you see a right triangle, 2 things can help you: the Pythagorean and the trigonometric. Here now, since I know only one side, I cannot use the Pythagorean theorem. So I can want to use now the trigonometric function. The trigonometric function, as I told you, sine, cosine, and tan. And in each one or in the other 3 elements that inshallah you will take it in chapter 14, you will need 2 sides and 1 angle. Here I have 2 sides, so I need an angle. To find an angle, as we said in the previous lesson, we have to find the area, the angle of the center. To find the angle of the center, we have to divide 360 by. How many sides for the pentagon we have? There are 5. So I will divide by 5. So 360 divided by 5 is 72. So the angle here is 72. And here also the big one is 72. So if the big one is 72 and the bisector cut the angle and also it cut the side, so what is the angle of the vertex angle, will be? It will be half of 72. Which half of 72, I mean it is 36. Now, is my triangle ready? Yes, I have 2 sides and 1 angle. Now, this is an opposite, this is an adjacent. As you see from here, if you need to find the apothegm, every time you need the tan. Why? Because the tan is opposite over adjacent. So the tan of theta is an opposite over adjacent. What is the opposite here? It is 2. The opposite here is 2. The adjacent here is A. And then tan theta is tan 36. What is the angle here? Is 36. The opposite is 2 and the adjacent is A. Then after that, A, it will be 2 over tan 36. 2 over tan 36. So the apothem here is 2.75. This is an apothem. Then let's go back here. Here now, I used I want to find the area of this shape. The area here, as we said, it is half the apothem, which is 2.75, times the perimeter, which is 20. And I mean it's 10 times 2.75, which is 27.5 inch squared. Is it clear?
Yes, teacher, it is.
Yes.
Now, in this one here, so in the previous 2 questions, they give me the side and he asked me to find the area. In this question here, he gave me the radius and he asked me to find the area. The radius. Okay, but the radius, that means I need to find the side and I need to find the apothem. So if you have a radius r given, so you have to find 2 things. In the previous one, the side is given, so you have to find the apothem only. In this question, you have to find the radius, the side and the apothem. Let's see here. A stop sign is a regular octagon. Octagon, that means we have 8 sides. So let's draw it here. 1, 2, 3, 4, 5, 6, 7, and 8. This is a stop sign with an octagon. Oh, the octagon sides. The standard side has a 16.2 inch radius. So the standard, he told me that everywhere, every time, the base, the radius of the stop sign, this is the radius, as I told you before. It is a line segment between the center of the polygon into the vertex of it, one vertex of it. So this is the radius, which is 16.2. What is the area of the stop sign near it to the square inch squared? I need now to find the area. As we know before, the area of the shape is half AB. He gave me the radius, so I need to find the perimeter, the side, and also the apothem. 2 things here I need to find them. This is, so look at this triangle here. In this triangle, this is an apothem A, the orange one, and this is side over 2. Why the side out? Because we said that this is S. So this big one, well, let's write as S first. So this big one is also s, but I didn't need s. I need only half of s, which is s over 2. So my triangle now is, here is 16.2. Here is, I told you that the side is s. So half of the side, let's write it as s over 2. And here there's an apothegm a. So now here we have the 16.2. We have a.
Can I write it as x?
Yes, yes. But after that, you have to multiply it by 2.
Okay.
So now 16.2, the apothegm, and s over 2. Now I need a angle. To find the angle, as we know before, let's divide 360 by how many angles for the how many sides, sorry, for the octagon? They are 8. So
It's
yes,
8.
sorry. So the angle here is 45. So now the angle here is 45. So the big angle here also is 45. And as we know, in right triangle, we need to write half of it here is 27.5, half of the angle. So now the given angle here is 27.5, and I have to find the apothegm s over 2, and the given side here to me is 16.2, which is the radius of the shape. Now look at this right triangle. I need to find the opposite, I need to find the adjacent, and I have the hypotenuse. So I will use the sine or the cosine. Now let's use sine. So sine theta is opposite over the adjacent. Opposite over hypotenuse. For this sine, which is 27.5, or for this angle, sorry, which is 27.5. What is the opposite side for the 27.5? It is s over 2. And what is the hypotenuse here? It is 16.2. Here, the sine of the opposite side is s over 2, and the hypotenuse here is 16.2. Then, by cross product, I will multiply 16.2 times 27.5, which is 445.5. This one is equal s over 2 times 2 times 2. So the side here, it will be 891 inch. So the side here of the stop sign is 89 So the side here is 191 inch. Then I need to find the apothegm now. Yes, Habiba.
Teacher, it's supposed to be 22.5, not 27.5.
Oh. Okay. Thank you for telling me. So. Thank you for telling me, because also I multiplied 22 by 16 without sign. I made a big mistake. So sine 22.5 times 16.2 is 6.19 is equal to S over 2. So the side here is 12.39 inch. This is now the side of the stop sign here. In the second step, after I find the side, I need to find the apothegm. Now, to find the apothegm here, as we see, let's say that this is an angle. Name it with theta, or name it with 27.5. Okay, I wrote as 27.5. Sorry, 22.5. For this angle now, I have an adjacent and I have an hypotenuse. So, shall I use cosine or sine? If I have an adjacent and the hypotenuse.
Cosine.
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 So, cosine 22.5 is the adjacent, which is A, and the hypotenuse, which is 16.2. Then to find A, you have to multiply cosine 22.5 times 16.2. So the answer is 14.96. By now, we found the apothegm, we found the side, then I can find the area. To find the area now, I have to say that I need the apothegm A, which is 14.96. And also, I need to find the parameter. To find the parameter, I have to multiply n times s, which is 12.39, that's we found it before, times how many sides for this shape? They are 8. So 12.39 times 8 is 99.12. So this will be now the parameter of the shape. So let's write here. So now the area is half AB. A, we found it here. Where's A? It is 14.96 times the parameter, which is 0.12. So the standard area for the stop sign is 99.12 times 14.96 divided by 2. So the standard area is 741.4 inch squared. So for this lesson, or for the regular polygon, if I give you the side only, you have to find the apothegm. To find the apothegm, you have to use the 10. But Now, before I summarize, did you understand this problem?
Yes, thank you.
So, okay. So, in the regular polygon, two things you have to know. In the regular polygon, you need to find the side and the apothem. Sometimes, if I give you the side and you need to find the apothem, you have to find the apothem using the tan theta. Then you can find the area.